This is my code for the homework 4 question 2 for ENME 435. So I have the importing of the test video at the moment. That name will change depending on which video you want to use. I have my initializations of the arrays for the different variables. Then I have this grab frame. As what the code does is it changes every single frame in the video. So first off, it will snip the region of interest in the video frame. So this code kind of came from lecture as well as the mask. So all it's doing is just taking the video and just like snipping it to these parts of the image that we're interested in for the lane detection, as we are not really interested in like too much of like the dashboard or the sky. We want just like the road. Next we have the tress image, and this is kind of just like where I do a grayscale. Keep in mind a note for later that I do have to change this the threshold value for each video, because each video has like a different lighting. So I'll demonstrate that later. So yeah, I also got that from lecture. Blur image. Originally I was gonna blur a different amount for every single video like I did with the threshold, but then I realized as long as we change the threshold to a certain amount, it will be able to detect everything just fine. Next, for the hue transformation, we have the line image, and then this is my code for the red lines that you'll see later. How it works is it'll take the coordinates and convert them and kind of just plot them based like that with the row. And we have the median array, and then plotting the final lines. Like this will be the green one for this one, and then later we'll have like the average lines, because what the code is doing is it's taking the like all the red lines that will appear, and it'll like average them out to create one single line that's like most accurate. So yep, just copy the image, storing the left and right lines. Right here for line and lines, for the left underscore lines append the row and theta. We are actually sorting each like value by theta. So if the lines tend to lean left or tend to lean right, then it's the left lane, and if it tends to lean left, then it's going to be the right lane, because the lanes come together like that. And then we have a blue line for the left one and the green line for the right. So it's just the same thing. Originally, I made the video for the full with the different line colors on the sides for these snipped values, or for the snipped video. But I realized that like we wanted for the whole video, so I have to do this slight offset because we need to realign it to where it's like supposed to be in the video. And then this right here is we're clipping the blue and green lines so that they're not just like going infinitely off the screen in the video. And then here are all my run commands. I have a lot of like proof of concept with like all these commented out like im shows, but I did want to display like the edged one, the red lines, and the actual value lines in the end. And the rest kind of just came from the lane detection.py. So as for the videos themselves, I'm going to first run the first video with the proper threshold. The threshold should be 60 for this one. So when I hit run, you can see like the edged ones, all the red lines, and then the actual true values here. So what I was saying is that like it averages all these red lines when I was saying before in the code, and then it'll make one true line. So because these are disappearing, the blue line will also like disappear and reappear at times. So yep, it's just going. And yep, I did notice that for this one, the threshold was a lot lower. This one was like actually 60. Yeah, so the lower threshold means that it's darker. So now that the threshold is 180 for video 2, I'll play that. As you can see, it is like a little bit brighter, but again, you can see the line showing up. It is relatively pretty accurate, I would like to say, as it keeps going. It did have some slight issues, or when we were merging lanes, as well as like when some signs cast a shadow, and as well as some cars cast a shadow. As you can see, the blue line isn't showing up, and I think it's just because it's having a hard time seeing it because the shadow of the car is like drowning out the thing on the line on the left, which is why it's not showing up on the right. As for the final video, I did rename the final video to just test video 3, just to make it a little bit more convenient for myself. But I found that a proper threshold for this one would be 150. And again, it works pretty well. So, yep, the one thing with this code is that I do have to change it, the threshold value every single time, and then I think that's just because the light is varying so much because it's like in a different spot, and ideally we would be able to like kind of standardize this, but this is like kind of difficult to do. I know I kind of did something similar to this with my work when I was working with microelectronic components, and I was analyzing images of like these like really small square components, and I was having to play with these threshold values a lot, but every single time I got a new set of images, they would be so varied that I couldn't just have like a set value of threshold, that it had to be like 100% vary. So I tried like messing around with like making a true grayscale or something like that, but even then it was like really difficult because the images would truly vary like so much, and it'd be picking up like random noise like all over the place. So this is my homework. So